Hello, mathematicians. Today we're going to be learning about algebraic expressions, more specifically about evaluating two-step expressions with two variables. To get us started, let's first go over what an algebraic expression is. An algebraic expression is a math sentence that includes numbers, variables, and operations like addition, subtraction, multiplication, and division. Be mindful that there is no equal sign, unlike an equation. A two-step expression is an algebraic expression with two operations. So some examples include, here we have xy plus 6, and here we have multiplication between the x and the y, and then we have addition. Here we have x over y minus 4, so x divided by y and then minus 4. Here we have x to the power of y minus 8, so we have an exponent and we have subtraction. And in all of these, we have two variables. Here we have evaluate AB plus 9 for when A is equal to 4 and B is equal to 2. We have multiplication between A and B, and then we have addition. And the first thing we want to do here is substitute our variables for their known values. So we're going to substitute A for 4 and B for 2. And notice that I put parentheses around the 2. This is one way to demonstrate multiplication, but not the only way. And if I had just written the 4 and the 2 next to each other, it would look like it said 42. So it is very important that you do show that there is multiplication between these two values. So here I have 4 times 2 plus 9. And according to order of operations, we do multiply first. So 4 times 2 is 8. And then 8 plus 9 is equal to 17. In our next example, we have evaluate 40 plus xy for when x is equal to 12 and y is equal to 5. So here in our expression, we have addition and multiplication between the variables. The first thing we want to do is substitute our variables for their known values. So we're going to substitute x for 12 and y for 5. And according to order of operations, we do multiply before we add. So 12 times 5 is equal to 60. And then 40 plus 60 is equal to 100. Here we have another example that says evaluate CD minus 20 for when C is equal to 25 and D is equal to 4. In our expression, we have multiplication between C and D, and then we have subtraction. The first thing we want to do is substitute our variables for their known values. So we're going to substitute C for 25 and D for 4. So now we have 25 times 4 minus 20. And according to order of operations, we're going to multiply before we subtract. So 25 times 4 is equal to 100. And 100 minus 20 is equal to 80. In our next example, we have evaluate 22 minus xy for when x is equal to 3 and y is equal to 5. Here we have subtraction and multiplication between our variables. The first thing we're going to do is substitute x for 3 and y for 5. And according to order of operations, we are going to multiply before we subtract. So 3 times 5 is equal to 15, and 22 minus 15 is equal to 7. Here we have evaluate g over h plus 12 for when g is equal to 20 and h is equal to 4. In our expression, we have division and addition. We have g divided by h plus 12. The first thing we want to do is substitute our variables for their known values. So we're going to substitute G for 20 and H for 4. Order of operations tells us that we need to divide before we add. So 20 divided by 4 is equal to 5, and 5 plus 12 is equal to 17. Next, we have evaluate 9 plus x over y for when x is equal to 14 and y is equal to 2. In our expression, we have addition and division. The first thing we want to do is substitute our variables for their known values. So we're going to substitute x for 14 and y for 2. Now, according to order of operations, we're going to divide first before we add. So 14 divided by 2 is equal to 7, and 9 plus 7 is equal to 16. Here we have evaluate j over k minus 2 for when j is equal to 28 and k is equal to 4. In our expression, we have division and subtraction. The first thing we want to do is substitute our variables for their known values. So we're going to substitute j for 28 and k for 4. Here, we have division and subtraction, but according to order of operations, we're going to divide first before we subtract. So 28 divided by 4 is equal to 7, and 7 minus 2 is equal to 5. In our next example, we have evaluate 19 minus x over y for when x is equal to 12 and y is equal to 3. We have both subtraction and division in our expression. The first thing we want to do is substitute our variables for their known values. So we're going to substitute x for 12 and y for 3. According to order of operations, we are going to divide before we subtract. So 12 divided by 3 is equal to 4, and 19 minus 4 is equal to 15. Here we have evaluate m to the power of n plus 8 for when m is equal to 2 and n is equal to 5. Here we have an exponent and addition. The first thing we want to do is substitute our variables for their known values. So we're going to substitute m for 2 and n for 5. Here we have an exponent and addition. So according to order of operations, we're going to evaluate the exponent first. So 2 to the power of 5 is 2 times 2 times 2 times 2 times 2, which is equal to 32, and then 32 plus 8 is equal to 40. In our next example, we have evaluate 4 plus x to the power of y for when x is equal to 5 and y is equal to 2. In our expression, we have addition and an exponent. The first thing we want to do here is substitute our variables for their known values. So we're going to substitute x for 5 and y for 2. So we have 4 plus 5 to the power of 2. And according to order of operations, we do the exponent first before we add. So 5 to the power of 2 is the same thing as 5 times 5, which is equal to 25. And 4 plus 25 is equal to 29. Here we have evaluate r to the power of s minus 4 for when r is equal to 8 and s is equal to 2. Here we have an exponent and subtraction. The first thing we want to do is substitute our variables for their known values. So we're going to substitute r for 8 and s for 2. And according to order of operations, we're going to do the exponent first and then subtract. So 8 to the power of 2, or we could say 8 squared, is 8 times 8. And 8 times 8 is 64, and then 64 minus 4 is equal to 60. In our final example, we have evaluate 90 minus x to the power of y for when x is equal to 3 and y is equal to 4. In our expression, we have both subtraction and an exponent. And the first thing we want to do is substitute our variables for their known values. So we're going to substitute x for 3 and y for 4. According to order of operations, we are going to do exponents before we subtract. So 3 to the power 4 is the same thing as 3 times 3 times 3 times 3, which is equal to 81. And 90 minus 81 is equal to 9.